Okay, we are um, coming towards the end of this quick 8-week course. Can't believe how fast they go. It's early Sunday morning, August 2nd, as I record this. Um, this week's topic: big data mining versus analytics. Fairly straightforward topic. So we'll get started. Um, okay, so your week 4 papers. I just finished grading. Yeah, we're in week 5, starting week 6 next week. Just finished grading week 4, everything for week 4. Um, got a little feedback for the group, and then just um, this week we're looking at traditional analytics, but then really talking about data mining. Um, and I've got a personal project to share with you, and I think we're going to have fun with the discussion this week. I hope we are anyway. So I'll go over the assignments. Okay. So writing tips. This is based on your week 4 research paper and discussion posts that I just posted feedback for. Um, I saw a lot, far too many papers that obviously started with another paper, um, and were almost identical, changing a few words here and there. Just not satisfactory. And it was obvious some of you were writing in circles. I read every paper, start to finish, every sentence, every paragraph, every paper, um, and made comments in there. I'm not going to do that again. Um, I'll just give an overall impression, because I don't necessarily believe that some of the detail I went into is appropriate for PhD level class. So that, yeah, please consider that sort of feedback your final warning, final detailed feedback. Um, Writing in circles. That's what happens when you just start writing and you don't plan it out. I had to remind almost everyone to review the week 2 lecture I posted, Academic Writing for Systems Engineers, because I'm just not seeing, um, I'm not seeing middle school level organization in some papers, let alone doctoral level. Something's got to change. If you're in that group that got less than a score that you might like, or some disappointing feedback, it's really time to change. I don't know. Maybe you've had professors in the past that didn't actually read your assignments, or you're hoping for future professors that won't actually read your work. I don't know. Don't know. Don't know. All I can do is just let you know where you're at based on my experience and judgment. Um, so start with an outline, okay? Not somebody else's paper. I saw the same paper many times, and I know where they come from. Um, and some of you are in study groups. I would ask you, if you're getting the result that you hoped you were, great. Keep it up. If you're in a study group and I commented about your paper negatively, perhaps your group should discuss that and change their approach. So I saw a lot of that. Obviously, not outlining your ideas, not planning your writing. Again, watch my week 2 lecture on academic writing for systems engineers. It's not complicated. If you guys can get a master's degree in computer science, you can certainly write an essay that has some organization to it. Um, Also, I provided an APA template. Actually, it was a version 6 paper I've been using for years. Um, but some of you used all of the headers, and without really paying attention to what the header said, you kept on going with your paper to just kind of make it look like it was in the right format. Whenever you get a template or a sample paper, don't be a slave to it. Okay, that doesn't mean because you got a template that what you turn in has to look exactly like that. It's a template. It's a formatting template. It's only intended to show you a potential format. Not every APA paper has to have those exact headers, and that's in your APA guide. It's out there online. It's um, very very common understanding of APA format. It's just a way for your paper to look so that it can be digested systematically. Um, when information comes at you in a certain format, it's easier for you to find what you're looking for, whether that's a Wikipedia article or Facebook posts. When things that you're used to follow a certain protocol, a certain format, it's easier for your mind to find what it's looking for. And that's why we have APA formatted papers, so that references, citations, paragraphs, headings, title page, all of that is where you expect it to be, so that you can absorb, digest, use the information in those papers more effectively. But I have included APA 7th edition sample student paper. Again, you're going to need the guide. There's a lot of details, how to cite figures, how to cite videos, how to cite websites and blogs, and versus academic journal articles and government databases. There are a lot of different um, citation rules and everything in APA. How to use a block of text that you feel is appropriate to cite directly. Um, Direct quotes versus paraphrasing. All of that's in your APA guide. So you need to hit the guide. And I mean, probably a third of the papers, the paragraphs weren't even indented properly. I mean, indent your paragraphs. Uh, that's so basic. It's distressing that I have to mention it. But anyway, there you go. APA 7th. Start with an outline, which is on my next slide. This is an outline. Okay. Uh, if you're unfamiliar with an outline, get familiar. Okay. It's where you sketch out the structure of your paper. Some things that you probably want to. This is a sample outline on radio. You know how they work. How do radios work? Radio waves. There you go. And then the radio industry is uh, the next major topic. You see, he's got Roman numeral 1, 2, 3, and 4, and 5 there. You need to sketch out something similar for your papers. If I tell you your organization's terrible and you're repeating yourself, it's because you can't intuitively sit down and write a paper. Now, when I did this, when I was writing my papers, I would start with the APA template, and I would chop out everything, and I would create headers in APA format that were my outline, so that I could um, then kind of construct my topic sentences. You've got a thesis sentence. Again, guys, this is in my week 2 lecture. You've got a thesis sentence, one sentence, hopefully, that encapsulates what your paper is about. and then your paragraphs follow that thesis sentence. If you say, you know, this paper will introduce how radios work, basics of the radio industry, uses for radio. That's your thesis sentence, and then your sections line up with that. This is easy, guys. It's easy. A thesis sentence. Each major section, each paragraph should have a topic sentence and should stick to that one topic. Uh, it was last week or the week before I mentioned the Dr. Frankenstein approach to assembling uh, papers from dead body parts, from unrelated, non-coherent, incoherent sentences from various papers in a desperate attempt to bring a paper to life. That's what that's called a metaphor. Uh, Dr. Frankenstein approach to academic writing. It doesn't work, guys. It doesn't work. It didn't work for Frankenstein. It turned out to be something horrible that the villagers burned down, you know. And it has the same result in your papers. Um, and I don't know. It's obvious to me. Perhaps it's not obvious to previous faculty members. But you need to write an outline first, and then write your paper in your own words, um, according to your level of understanding of the topic. Don't write beyond your level of understanding of the topic. It becomes obvious when you do that. So use an outline and then fill in uh, your paragraphs and your sections, you know, in APA format to a level of analysis that's appropriate for a doctoral level student, and everything will be fine. So start with an outline. Don't start out with Shravan K Hadoop 15, I think was the username on Course Hero at the top there. So yeah, he decided to post his week 2. This is, you know, quite a while ago in some other section of ITS836. But 5 people are thinking, "Hey, Shravan, thanks for that week 2 homework that I just copied and used in my class." Um, but you don't know that anything you're finding on Course Hero is worth you don't know what grade they got necessarily. You don't know if the current professor has the same level uh, um, of expectations. And then I found another one, another couple, studyguide.com, the bottom one from Mr. Narendra Reddy Kodamula, a little less than a year ago. He posted his ITS 836 assignment for everyone to cheat, to use. So there you go. It's all over the internet. And I could see um, a lot of you using the same basic paper that didn't really do too well for you. So just take that into consideration. Um, Start from scratch, do your work, write your own paper, set aside set aside anything that your study group may present to you that you're working from that's not your own idea, your own outline, your own creation, because it's just gonna get you into trouble. And if you're using internet sources like these as opposed to academic journal articles themselves, um, you get what you pay for, and um, you're getting what you deserve. Actually, uh, uh, don't do it. Just stop. If you are, stop. If you're not, great, great. I could tell some of you got really high scores. Well, high 70s and 80%. Um, and if so, uh, keep it up. And if you are starting with someone else's paper, you're doing a much better job of of assembling things than other folks. So there you go, guys. It's really late in the course. I'm probably going to get some requests to resubmit, and I will tell everyone no. I don't allow resubmissions, and the writing expectations in the syllabus are clear. Um, uh, I, I'm sure everyone knows what's expected as to just whether or not they're willing to put in the work and the time and the effort to actually do the original work and become someone that we can be proud to call doctor. That's where I'm at. I'm unfortunately placed in the role of instructor and gatekeeper, um, to enable people to succeed as PhD candidates, um, but also to prevent anyone from proceeding in the program that's not willing to put in the work and the effort and be original. All right, enough about that. We'll move into this week's content. Traditional analytics is what everybody's used to. Follow some sort of a structure, some sort of an analytics plan, like the typified by the BI cycle that we covered last week. Traditional analytics will start with some sort of a question or a hypothesis that has to be proven or disproven. And very often the teams and the processes and the tools are well documented. That's really more your traditional approach to analytics. So your data is cleaned, or at least there's a process to clean it, and you're trying to repeat the same set of metrics, perhaps as like you do in a BI cycle. You're just really refreshing the numbers every 10 minutes, every morning, every week, whatever the case may be. So that's traditional analysis, traditional analytics, very structured, um, for a given purpose, um, according to a certain structure. And then we moved into data mining. So this is where we're really talking about the concept of data mining in more depth. And I have one data mining project that I actually a big data mining project that I'm going to go over. So traditionally, data mining, and you'll see these definitions all over the internet and all over YouTube, and in your textbook. Data mining, actually, I don't remember there being a whole lot on data mining in our textbook, um, because data science is really more about advancing the methodology for doing data mining and whatnot, really more than data mining itself. Um, so data mining is not traditionally tied to a specific question or hypothesis. Data mining is very much like the prospector going out with his pan and um, trying to find what metals are available in the earth, or doing a core sample, to see what's out there, what is available, without necessarily um, knowing what's in the earth. And for data mining, it's we don't necessarily know what's in the data, which is the exact problem I had with the project I was working or managing before I retired. It seeks to find relationships between different data items, or just information in large and data sets. And again, you might be unfamiliar with the data. If you're very familiar with the data, you're probably not data mining anymore. You're probably doing analytics. So that's kind of the data mining is a small subset of data analytics or data mining, or I mean, data science. So it's a small subset where you're just figuring out what you've got, and depending on where you're at, you'll eventually your data mining will result iteratively in a more structured data architecture, perhaps a data warehouse. As you go through this pile of data you have that you don't really know much about, you may find that, oh well, there's some good information here. There's some relationships. that I can use, and I'll move that. I'll clean it up. I'll structure it, and I'll move it into our data warehouse. Um, but so we've been doing data mining, in the literature for years, 20 or so at least, and big data injected um, all of the V's in there, to kind of change up what we're doing. And it entered particularly the variety, I believe, the variety, which is the unstructured and semi-structured data, in addition to your traditional, flat files and relational database tables and whatnot. So now we've got, this all of this unstructured and semi-structured data, and depending on the size and the nature of the organization, it just gets more and more complex. Um, Videos and images, which you can extract text from, if you have the location data and the temporal data. You can start to extract, quite a bit of information, from those types of data. But then you've got connections, networks, and posts and tags and likes and shares and all of those things from social media that can be assembled to create some sort of a picture of what's going on. You've got mobile device data writ large. I said metadata, just hopefully they're not looking at your actual data, your actual texts, but I think the larger metrics are certainly there. We talked about that recently. Then you've got IoT sensors, um, bringing in, um, uh, as we saw, like smart city. Um, one of you is working, diligently on smart city technology, and the sensors that are available there for traffics and amount of pedestrian traffic, aggregated through a camera, gunshot sensors, where first responding units are, the status of utilities, current amperage draw per city block or per the power grid. There's just an enormous amount of data coming in, and depending on who you are and what you're doing with that data, you may or may not know how it relates, how it interrelates, and what new information can be drawn from that giant pile of data. So you got to do data mining and start to figure it out. Again, I've got one data mining project that I worked on, big data mining project. I mean, I've done a small scale. We've all pulled up a data set and ran little charts and descriptive statistics and whatnot. But this was the one project I really worked on, for years, and it was still ongoing when I left that organization. But that's your data mining. You're looking for hidden gems within the data, that can be used to drive business decisions, that can add some worth. Data mining isn't being done for fun. It's being done to either lower cost or increase efficiency, or provide some benefit to the organization. Uh, just for example, you pull up a data set. This is data on flowers from the Seaborn data set, which is a library. I've used it in Python. I think you can use. I think it's available in R. But you'll see this particular data set being used pretty widely. It's the correlation between different parts of a flower, the sepal and the petals of the flower in a given species of flower. I'm trying to remember what it was. If it was, well, there they are: Setosa versicolor, virginica. I think that they were hibiscus flowers. Anyway, this is particular types. The blue, orange, and green are different, um, species of flower, and you can start to see uh, that like petal width and petal length are correlated highly. So the this quadrant here, or they're very tightly clustered, along with uh, petal length and sepal length. See, when you got the this matrix, uh, it's correlated with so this cell here would be sepal width and petal length correlated, and it's quite different than some of these other uh, um, bivariate pairs, these data pairs. And this is just an example of a technique. The scatter plot matrix is something you can generate, particularly in these coding languages. I haven't actually looked into it with Excel, but you can choose um, various continuous data columns, and make a scatter plot matrix that will examine them each. And as you see here, this is these distributions are used for where there is no matrix. You know what I mean? You're looking at the same thing. Petal length versus petal length. See that? Sepal width, sepal width. So they just show the distribution there of those data points versus a correlation, because it's the same. So anyway, yeah, scatterplot matrix could be something that you run in an initial data mining exercise. Um, and again, depending on the variety of the big data, you're not going to be able to run something nearly as simple as this. But then, you know, there's a lot of people. This next one, there's a lot of people that cast aspersions on the good old word cloud. But to me, if you've got unstructured data in the form of a textual document, or many textual documents, and you just want to start kind of getting the overall themes that are in there, like what are these documents mostly talking about? I think a word cloud is pretty useful, and there are lots of different generators online here you can use to generate a word cloud. But this, I saved my dissertation in text format, plain text, and submitted it to a word cloud generator. And this word cloud generator uses um, word size um, to indicate the frequency, and then it proximity within the document of each other gets it closer to the center. Um, so I obviously use the term joint a lot. I use knowledge the most. This study, when you're writing your dissertation, you will try and figure out different ways to refer to things, but you're going to use the word study a lot and research. But you'll also see other things in here that sort of clue you into what sort of dissertation this was. The word qualitative on the right side. Mine was a qualitative examination. Um, Knowledge loss was absolutely part of my research question, so I'm repeating that over and over and over again in the dissertation. So yeah, you can get an idea of what's in a large group of documents or in a single large document by running a word cloud and just checking out. It's an indication. It's not something that you would authoritatively use as a quantitative measure of anything. It's just a data mining tool to let you know what sort of text is in there. And you could do the same thing with like image recognition. Like there's a Python library out there and a off the shelf text extraction program. You can start pulling text off of pictures. So you could go online and you could if you wanted to do a study of the text from different phenomenon, you could go to a Joe Biden rally and start pulling text off of people's posters and T-shirts. Then you could go to a Trump rally, start pulling images off the internet. And you could run those through a text extraction um, exercise, and then submit all of that text to a word cloud generator. I'm sure it would be illustrative. It's not something I'm going to do for this class, but it would tell you the themes of the people at a Biden rally versus a Trump rally, of what they're interested in, um, what their particular political agendas and priorities are. So just an example. There's just lots and lots and lots of information that you can do through text extraction. So I think here, yeah, this is the only big um, data mining project that I got to be involved in, and I supervised it. Um, I was running the records management effort and and Freedom of Information Act office, and major declassification programs. Information management. I was working information management issues at a large military headquarters, the headquarters that is in charge of um, the Southwest Asian theater, from Egypt all the way over to Pakistan. It's called United States Central Command. So I was working there from '09 to 2012, and as we were drawing down significantly from Iraq, we had a significant information systems architecture infrastructure that we had assembled over there between 2003 and 2010 or so, when we started working this 2009. Um, So we had lots and lots and lots. We had thousands of people working at what would be like a corporate headquarters level. So they're working large scale projects, priorities, contracting, writing operational orders, deciding the priorities, intelligence gathering and reporting, um, rebuilding projects, uh, everything, press releases, everything you could think of that's going on inside a theater of war was going on in Iraq, and very soon we were about to draw down Afghanistan, and that was even worse. But the headquarters in Baghdad was where, like, General Petraeus worked, and he had, I don't know, almost 1,000 staff members at any one point in time, working 12 hours, sometimes more shift, generating content, generating emails, generating documents, photos, videos, PowerPoint slideshows to advise their chain of command on things. So just a mountain of data is piling up with and it's wartime, right? So it's like a really, 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 really busy corporate headquarters. They're generating this data without really necessarily a firm data governance plan in mind, or even a records management plan in mind. They're just working and storing things, and working and storing things. And so at the end, when we, no kidding, we're going to withdraw from Baghdad, except for the little tiny security cooperation organization in the green zone. When we're pulling out of Iraq, uh, we are left with not the the little operating units out in the field, not the platoons and companies and brigades of the army, but just the joint headquarters, just the corporate staff, at the General Petraeus level, um, produced. They had, I think it was 47. I can't remember. It's been 10 years. 47 terabytes of. There was some structured data in databases, but it was mostly traditional file shares on both classified and unclassified networks, and SharePoint sites that were extracted basically in their totality. And the unstructured documents on those shared drives included a bunch of PST files, which turn out to be text, and as you know, you can fit a lot of information in text, in a 500 megabyte PST, say. So there was just an enormous amount of data, of big data to go through. It was so much data that the network wouldn't allow retrieval. We could not get the various shared drives that were being used around, two or three different buildings. We couldn't get it all home on the network. There wasn't room. And when we talked to the folks that lease new bandwidth, it was cost prohibitive. So we sent a young major over, with a storage area network on a pallet, and he trucked that storage area network to three or four different locations, hooked it into the network, and started hosing off records. There, they were still in operation, so some stuff was created after we left. But we waited as long as we could, as things were drawing down, and pulled off, like I said, almost 50 terabytes of files. Um, and then we went data mining. Oh, by the way, no big data tools. So we had no cloud-based elastic, server farm that we could throw resources at in order to help our text mining software. It was basically installed on not even its own dedicated physical server. The application server was a virtual server you know, on a traditional local area network, and it took a long time to plow through the data and get any sort of reasonable information or intelligence out of it. So when we started, we just wanted to know basically what we had. So we were looking at sizes. We used a program called Active Navigation to look through. We had uh, 8 or 10 multi-terabyte file shares, both classified and unclassified information. And we went in looking for information. So we mapped out the file structure, the folder structure, which is the topology of the data. We looked at metadata statistics of, dates of creation, but I believe that got disturbed when we copied the data from its original source over to the shared drive. It seemed like we lost metadata in that transfer, but not necessarily all of it. So we went looking for that, you know, dates of creation, and lumping the data into years, and kind of looking at how much was more recent, how much was older, was the more recent data more valuable. We went looking for duplicates. One of the very first searches was mining for classified markings, um, particularly top secret, which was above. We shouldn't have had any top secret data, but occasionally people, especially over in theater in a wartime situation, will use perhaps a thumb drive when they shouldn't have, and you'll get leakage. Uh, we didn't find much of that at all. It was pretty solid as far as finding classified information. But when we did, we had to shut the whole thing down, cleanse it according to procedures. But we also went looking for PII, and it was massive. It was huge. The amount of social security numbers and addresses and things where people would store, like, their annual review, or maybe somebody was doing a bank loan back home, and their work computer was the only computer they had, so they're putting all of this personal information, their taxes, so people are using the computer network for some personal business, which, not a huge sin when you're working 16 hours a day in the desert 7 days a week. But anyway, so we had to go through and cleanse all of that out, and then we started moving on, looking for, once we had things semi indexed, which takes a long time to build an index off of unstructured data. And it certainly wasn't a full text index. I couldn't look for the term, you know, uh, explosion, and just go, oh, well, here you go. It's in these 75 million files. I couldn't do that. Um, Maybe we could have, if there had been a much more robust hardware environment, cloud-based elastic hardware environment, and something like the Hadoop file system to break out the data. More advanced text mining, I'm sure we've come a long way in 10 years, especially the cloud-based data mining tools are proximate to the data. Um, so there's a performance gain. They're often in the same data center. So we probably could have found out a lot more than we did, but we went on to looking for relationships within the text and the files. We none of this was intelligence information. That's all stored in ongoing structured databases. But we started looking for relationships between certain entities, like tribal leaders and tribes and areas, so that we could start looking at across the topology, across the folder structure, and start assembling data based on um, topics versus functional areas. That's most folder structures are like, the finance department creates a folder structure, and then operations creates a folder structure. And sometimes there's information, across those stovepipes, those functional stovepipes. So we started looking for those sorts of things. And then blissfully, I retired from the US military in 2012. I believe that project is somewhat ongoing. The entire the legal need for the project was that we had to transfer. You have to transfer permanent records to the National Archives. They're part of our national history. The documentation of that conflict are permanent records that need to be stored with the National Archives once the organization that created them no longer needs them for ongoing business. So not only were we doing that, we created a backup copy of that entire collection and sent it to the National Archives for safekeeping. And then we started working on cleansing it, because there's a lot of that stuff that is not record material. It's not supposed to go to the National Archives, like people's tax returns. So you're allowed to delete that stuff from a record collection as part of your ongoing maintenance. But anyway, that was my big data story, data mining story. And it would be a case study. It would be considered a case study, I believe, in research methodology. Okay, so on to your assignments. Okay, so for the research paper, I want you to focus on findings. Okay, we're going to talk data mining findings. Okay, so don't write an overview of uh, data mining or data analytics. Okay. Um, when I asked, on the week 4 paper, don't write an overview of visualization. That didn't. Uh, some people didn't watch the video. Some people didn't get the memo and wrote an overview of data visualization without respect to the instructions, and they probably aren't happy right now. So these are the instructions. Okay. We're going to focus on findings. So write a short overview of data mining as it relates to data analytics, 3 or 4 sentences. Okay, guys? Do not go into any detail. Uh, Make sure you create your outline first. And in your introduction, you'll see that it's a very short part of the paper. Okay, so then I want you to analyze 2 or 3 data mining projects, which would be case studies similar to the one I told you about, which I never wrote up. I never, other than the press release of us getting the records, which I posted to the classroom. I never wrote this up at all. Okay, so I want you to go out there and find a couple, 2, 3 data mining projects. Try to find them that have a big data aspect to it, and how that change the program. Okay, so there's, for each of your data mining projects, you have 2 sections. Okay, you're going to provide a summary of the project. What business area was it in, and the landscape of the project, but focus on the findings. Okay, so I guess that's actually three sections for each data mining project: summary of the project, the and the findings. So actually, I'm missing a closed paren. So I'm going to fix that right now. That should be a closed paren. There we go. Okay. Now I'm happy. So yeah, focus on those angles. The domain of the problem. What was the data? What was it in? You know, was it structured? Was it semi-structured? Was it social media data? Was it corporate financial data? What was the data landscape? The data architecture, the situation with the data. But what I want you to spend that those two things, the business domain and the landscape of the data, that can be 3 or 4 sentences. All right. So write a page. Try to write half a page on what they found. What did they learn in their data mining in that data mining case study? Okay. So 2 or 3 of those, bam, you're done. All right. Um, I'm gonna include a different template this week. It's an APA 7 sample student paper. And again, please do not be a slave to that student's headings. Um, Good grief. I got in a big hurry. That will not be in there. That will be different. Don't look at that. Okay. That is accurate. Um, um, I would like to see academic references, as always, but your case studies can be from practitioner sources. Many of these case studies, you will see case studies in academic journal articles, but a lot of times you'll get something that's more readable and understandable as a white paper or a blog entry or an article in Forbes or something, Fast Business, something like that. Um, uh, so you can use the case study from a practitioner source. So write, you're going to write, an academic paper as always, but um, um, it's okay to cite non peer reviewed journal case studies. Okay. If you have any questions on that, as always, feel free to email me. And then the discussion. Now, this week, I'm hoping that we're going to have a little bit of fun with the discussion, and we're going to completely avoid I want to add a few points nonsense. Okay. I hope. I try and take the pressure off you guys, and some people just do not take advantage. Nothing I can do about that. So I'm hoping this discussion turns out to be fun and informative. Okay. So please don't try to sound like a PhD in your initial reply responses. Okay. Just write in your own words, conversationally, professionally, like you would at work. You don't want to sound, you know, uh, like an idiot at work. You don't want to sound like an idiot in class discussion, but don't try to mimic what you're seeing in some of these articles as if that's the expectation, because it's not. So I'll keep saying that. Some of you will get it, some of you will not. Okay, so for this discussion, I want you all to imagine you could assemble all the data you wanted from known information systems on planet Earth. Not new data, not, you know, godlike omniscient powers, but think about all of the data that we know exists out there, because we all live a highly digital life, and we're all, doctoral level. So there you go. Imagine you could do that. Don't don't worry about privacy. Don't worry about it. Imagine you could assemble that. What would you look for? What would you look for in a data mining project? This is fun, right? This is something for you to think about. Golly, if I could assemble all the data I wanted, what would I look into? What could we find out about? I'm not going to even poison your mind with ideas. Okay. Remember, though, that data mining is meant to go from being a position of ignorance. I don't know what's in this data to gaining insight from it. So don't go in. Don't use this little fun exercise because you already know the answer or something like that. Just use your imagination. What would you assemble data from? You know what I mean? So I'm going to use the post first feature, so nobody should be able to see the discussion board until they post something. So I am expecting randomly for people to come up with different answers. So if I start seeing the same answer, I'm and you guys are in study groups. I know. I'm going to be disappointed, and disappointment for me usually has a quantitative measure as you're finding out in your grades. Okay, guys. So use your imagination, uh, and please don't collaborate with anyone in this class on what your idea might be. What would you look for? What data would you assemble, and what are your research questions? What would you look into? What do you want to find out? We've got folks from various areas here. I'm not, like I said, I'm not going to uh, poison your thinking by giving you any ideas about how to approach this. Um, if you don't understand the concept as I have put it out and written it down, email me. Okay, please don't guess. A lot of you are guessing, hoping that what you're turning in makes sense. And guessing and hoping are not um, techniques that doctoral level students use. Okay, bottom line, last bullet. Keep it professional and conversational, but don't try to sound like a PhD. Okay, so many of you are. That was a very good post. Want to add few points, and then you just spout basic, factual, useless background information into the discussion post. That's not what the discussion is about. I'll keep saying it, even though my words are largely falling on deaf ears. Um, yeah, please don't add a few points. Actually discuss the issue with your colleague. Discuss. You don't just walk into the 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 staff meeting. You don't just walk into the conference room and start spouting basic facts that everybody in the room knows, but for some reason you're taking that approach in this class uh, sometimes. So if that applies to you, please stop. If it doesn't apply to you, hey, keep it up. I'm loving some of these posts. I'm particularly loving when classmates hold each other accountable, because that's what happens in academia. That's what a peer reviewed journal is. Your peers are going to review your work and tell you if it's of sufficient quality or if it's garbage. And you all need to get into that frame of mind in this program. Get with the program and hold each other accountable. Some of you are, some of you aren't. Some of you are being very delicate about it, and that doesn't work. That doesn't help. Um, so yeah, hold each other accountable. That's what professionals do. That's the definition of a profession, a self-policing organization. So there you go. There's your two assignments for this week. Have at it. I'll see you in class.